Okay, here we go. Our objective for today, can factor polynomials. Let's read together. 1, 2, 3. Can factor polynomials. So if you notice, we're back on polynomials. You probably noticed that over the weekend when I left you the homework and you went to watch the video and so on and so forth. We introduced polynomials at the beginning of the year. We've been looking at polynomials throughout when we do the cumulative reviews, right? So here we're back again. Today, we don't need a Ferrier model for polynomials because we know what they are, but we do need to clarify in regards to certain terms that I'm going to be using throughout the lesson. So polynomials, what were they? Monomials or sum or difference of monomials. I remember when we went over this. This is a monomial, this is a monomial, this is a monomial, and they're being added here. That's a sum of monomials. Monomial, and here's a subtraction, so that's a difference, and in addition, it's a sum. These are not examples because they're equations, so they need to be expressions only with various terms. Remember that? Kind of, sort of? All right. Steps. Copy these down, please. And you can abbreviate if you want. For step 1, it says steps. Identify the greatest common factor for every term. Step 2, rewrite the polynomial using GCF and the remaining expression. And in parentheses, I wrote as factors, and at the end, check your answer. So once again, step 1, identify GCF for every term. That's important, every term. Step 2, rewrite using GCF and remaining expression. And at the end, check. Copy that, please. All right, so here we go. Basic steps, 3 basic steps. Let's clarify some terms, though. On the Q side of your Cornell notes, copy these terms, please. The first one, factors. Factors are numerical and variable expressions that multiply to give a product. Factors, numerical and variable expressions that multiply to give a product. Then you're going to leave a space there, and then second term, factoring. The process of finding the factors of a number. The process of finding the factors of a number. Copy those two. So for factors, let me show you an example. Example. It says numerical and variable expressions that multiply to give a product. 2 times 3. Those are factors. Is it a numerical expression? Yes. Are they multiplying? Yes. And they will give me a product. Okay. How about 2 times 3x plus 1? Let's see. This is a factor. This is a factor. Are they multiplying? Yes. Those are also factors. So now check this out. What is the product of 2 times 3? 6. So look at this. So for factoring, example, for factoring, let's say they gave us the number 6. To find the factors of 6, check this out. What number can divide into 6? 2. Okay, so 6 divided by 2 is 3. And so therefore, what are my factors? 2, 3. But what is the process that I use to get the factors? Division. So from now on, whenever you hear the word factoring, or when they say factor, please, they're referring to dividing. Dividing. So the process to find the factors is called factoring, which is dividing. Always. Okay? Everybody got it? All right. So, and here, one thing that I wanted you to notice is that when we came to polynomials the first time, remember that we started multiplying using area models and stuff like that? So what was the key word that I just said? We started multiplying, right? And look what we're going to be doing now. So now we're doing the opposite. Everybody with me? All right, here we go. Copy this one down. Example 1a, it says factor each polynomial, check your answer. Factor each polynomial, check your answer. And it gives us 2x squared minus 4. What's that? Yes. Example 1A, factor each polynomial, check your answer. 2x squared minus 4. All the black text, yes. Not these, yes. Be nice. So copy that, please. Pens down, eyes up here. It says factor each polynomial, check your answer. So according to the steps that we just wrote, step 1 is identify the GCF of every term. So let's see. Greatest common factor between this one and this one, I see that it's 2. That's my common factor, greatest common factor. So then it says step 2, rewrite it. Just pay attention, please. Rewrite it so that you write your GCF and the remaining expression. Check this out. Since we said we're factoring, what did we say factoring meant? Divide. So let's see. What is 2 divided by 2? 1, and I'm left with x squared. What is negative 4 divided by 2? Negative 2. Copy that, please. Then I'll show you how to, for those of you that don't see it yet, I'll show you one extra step if you want to do that extra step. Copy that. Pens down. So for those of you that don't see it, here it goes. Let me show you. In the past, I've told you that when in doubt, factor out. So this, to factor this one, this is 2 times x, minus, this is what? 2 times 2. Are we there so far? So what is common here and here? What do they have in common? 2. That's how we get this number. What's left? X squared. Here we have the minus and the 2. That's how you get that. Now, another way of looking at this, everybody look up, please. Another way of looking at it, since I know it's division, for some of you that need to see it a different way, I'm going to write the first term. 2x squared, and according to me, GCF is 2. Divide by 2. Do you see the giant 1? What's left? X squared. That's how we get that. Let me rewrite the second term. Negative 4 divided by our GCF. What is negative 4 divided by 2? That's how we get that. Okay, I'm just showing you different views so you can see it. But I'm not going to be doing this step often. This is if you have doubts, you need to factor out. Okay? Now let's check. Let's check to see if it's correct. I'm going to write this one. 2 times x squared minus 2. And to check, all we have to do is the inverse of division, which was, now we multiply. What is 2 times x squared? 2x squared. What is 2 times negative 2? Negative 4. Is that the same thing that we started with? Yes. Copy that, please. Okay, copy this next one down, example 1B. Copy this one. It says, you don't have to copy the instructions anymore, you already have them. Example 1B says, factor each polynomial, check your answer. We got negative 14x minus 12x squared. Okay, let's do this one together. So, GCF. What number divides into negative 14 that divides into negative 12? Think about it. Don't say it out loud. It looks like negative 2. Is that correct? Mm-hmm. However, everybody look up. What else does this term have that this term has? X. So my GCF now is negative 2x. So here we go. Didn't we say factoring was division? So let's see. What is negative 14x divided by negative 2x? 7 and positive, okay. What is negative 12x? No, not x. Watch. X over x, that's 1. Is that correct? Negative 14 divided by negative 2, that's 7. So with that same idea, negative 12x squared divided by negative 2x. It's what? Positive 6. And x squared divided by x leaves us x. That is correct.
So it's just like dividing x and x, then you just like cancel it out?
It's yes, because remember we're subtracting the exponents. Yeah.
You know how like we got the GCF with negative 2x? What are the numbers that have a variable? What are the numbers that have different variables?
As long as the number is the same, you factor it out.
So what if it was like negative 14 minus 12?
That's what I'm saying. The numbers, you factor out the number. You understand? Not the variable, just the number.
If one doesn't have it, you bring a number?
Just the number, not the variable. Yeah. Okay, here we go. So how do we check this? Let's see. We do the inverse of division. We multiply negative 2x times 7 plus 6x. Distribute. This is negative 14x. This is negative 12x squared. Did I end up with something that I started with?
Yeah.
Yes, that is correct. Let's do another one. Example 1C. Does everybody see?
Yeah.
Okay, here we go. Copy this. Example 1C says, factor each polynomial. Check your answer. They give us 8x cubed minus 4x squared minus 16x. Let's do this one together. Let's see. By looking at it, find the GCF for each term. What number or greatest common factor divides 8, that divides negative 4, and divides negative 16? 4 is correct. Now, why didn't I say negative? Because all three of them need to have the same thing. If this had a negative, then I would have said what? Negative 4. But since only these two have negative, then I don't say negative 4. However, I'm sorry? Yeah, go. No, they all need to have the same one. All of them have to have the same sign. Uh-huh.
Yes, but I'm saying, what if it's positive and it's negative, it's still be positive?
It's still positive. I'm saying, all of them, in order to get a negative factored out, all of them need to be negative. As soon as one of them is not, then you don't factor out a negative. Yes. No. All of them need to be negative. For it to be negative. Positive all the time. All right. So we got the number. What variable can I factor out of each term? X. So let's see. Let's see what we have left. What is 8x cubed divided by 4x? X squared. What is negative 4x squared divided by 4x? Negative 1x. What is negative 16x divided by 4x? Negative 4. And let's check to see if it's true. We got 4x times 2x squared minus 1x minus 4. Distribute, this is 8x cubed. Distribute, this is negative 4x squared. Distribute, this is negative 16x. Did I end up with this? Yes. Now, let me elaborate on this one for those of you that are still having a hard time following. Here it goes. Pens down, please. Eyes up here. Check this out. Once again, in the past, one of the things I said, when in doubt, factor out. So this is where the first lesson that you watched on video plays a role. Check this out. What is this one completely factored? This becomes This one, 2 times 2 times 2. Is that correct? And this one is x, x, and x. Are we there? This one becomes negative 2 times 2. And this one is x and x. Are we there so far? This one becomes negative 2 times 2 times 2 times 2 and x. Now you are able to see what is the same in each term. Does each one have an x? At least. Yes, there it is. Does each one has 1, 2? Yes, yes, and yes. Does each one have at least another 2? Yes, yes, and yes. So my GCF is these 2 2's and 1 x, 2 2's and 1 x. So what is 2 times x? 4x. What's left on my first term? 2 times x, that's 2x squared. What's left on my second term? Negative x, or negative 1x. What's left on my last term? Negative 4. Did you see that? Do another one. Example D. Copy that. It says, factor each polynomial, check your answer. 3x cubed plus 2x squared minus 10. See if you can do that one by yourself. Okay, here we go. Let's see. What divides 3 that divides 2 that divides negative 10? 1. Yes, if there's nothing else, then 1. How about variables? Is there a certain variable on each term? No. No, it needs to be the same on all terms. If there isn't, so therefore 1 times 3x cubed plus 2x squared minus 10. And it's obvious if we check it, it will be the same, right? Yes. Okay, let's, okay.
What if, like, number 10 has cubed?
Nothing. Same thing. Yeah. Yes. Copy this one. Example 1E. See if you can do this one by yourself. Go. It says, factor each polynomial, check your answer. 8 x to the 4th plus 4x cubed minus 2x squared. Go. Okay, here we go. So, by looking at it, it looks like GCF is, so far with the numbers, we start with the number 2, is that correct?
Yeah.
2 divides into each term. What else can we divide into each term? X. What else can we divide into each term? Squared. 2x squared. Okay, we'll get there. Let me double check that. So let's see. 8x to the 4th divided by 2x squared, that's 4x squared. 4x cubed divided by 2x squared, that's 2x. Negative 2x squared and divided by 2x squared, that's negative 1. Now, once again, when in doubt, factor out. Here it goes. If you don't see it, you need to factor it out, people. So those of you that are asking a lot of questions, you need to factor out, please. Do that step. This one, 2 times 2 times 2 times x times x times x times x. This one, 2 times 2 times x times x times x. This one, negative 2 times x times x. So, by looking at it, how many x's does each term have at least? 2. 2. 2. That's how we get the x squared.
How do you know that you need only 3 2?
This one?
Yeah, how do you know you only need 2?
Remember the homework the other day? Okay. All right. And if we were to check by distributing, let's check that. Distribute. This is 8x to the 4th plus 4x cubed minus 2x squared. Is that the same as this? Yes. Once again, if you don't see it, what are you going to do? Factor out. When in doubt, factor out. Copy this one down, please. Example 1F. See if you can do that one. Go. Example 1F says, factor each polynomial, check your answer, negative 18y cubed minus 7y squared. Once again, if you don't see it, what are you going to do? Factor. This is negative. To get 18, let's see if we get our factor tree. We got 2 times 9. This is 3 times 3. So this is 2 times 3 times 3. This one is what? Y times y times y. Next. 7 is a prime, so therefore minus 7. And this is y times y. What is the same here and here? The 2y. So that means we write y squared. What else? The negative. See how that worked now? Since both have negatives, that's where you get that one out. How about numbers? Anything in common on the numbers? No. So let's write our, whatever we have left. What's left on this first term? 2 times 3 times 3, that's 18 and 1y. And what's left here? Well, of course, that's what I said, yes. So if you don't see, you need to factor it out. So what's left here? 7, and it's a positive 7, right? And that's it. That's it. And to check it, let's do check. Negative y squared times 18y plus 7. Let's see. This times this, we're left with negative 18. Y squared times y, that's y cubed. Negative y times 7, that's negative 7y squared. Did I end up with the same? Yes. All right, let's move on to funner stuff. Copy this one down, please. Example 2. Copy that.
Yay!
Hurry up, please. The area of a court of the game squash is 9x squared plus 6x meters squared. Factor this polynomial to find the possible expressions for the dimensions of the squash court. I'll explain it right now. So, if the court looks rectangular, let's see, something like that, and they're saying that the area of the court is how much? 9x squared minus plus 6x. Doesn't this look familiar? Oh yeah, Mr. Q, you showed us the area model a long time ago. Yay! So therefore, now we're doing that back. Instead of multiplying, now we're trying to get the dimensions. Check this out. So what number divides here that divides here? 3. Okay. So that's our GCF, 3. What else divides here and divides here? X. Bless you. So now let's see. What do we have left? So what is 9 divided by 3? 3. What is x squared divided by x? X. What is 6x divided by 3x? Positive 2. So therefore, the dimensions of the court are 3x times 3x plus 2 meters squared. 10 cubed. What? Okay. Example 3. Copy this. Example 3, A and B. Here it goes. It says, factor each expression. Copy those, please. A, 5, open parentheses, x plus 2, close parentheses, plus 3x, open parentheses, x plus 2, close parentheses. And B, and leave a line here, a space, and then next, B, negative 2b, close parentheses, b squared, I'm sorry, open parentheses, plus 1, close parentheses, plus open parentheses, b squared plus 1, close parentheses. Okay, now I'm going to go over A really quick. Check this out. Now we have a binomial right here. This is one term. This is two terms. How do I know that? Because now there's a plus in between. Everybody see that? So if there's this plus in between, now I know that I need to find out what's my greatest common factor. What does this have that this has? X plus 2. Don't both have x plus 2? What do we have left? Let's see. For the first term, what's left? 5. And then the plus. What do we have left for the second? 3x. Copy that. And these are my factors. And this is what we call a binomial because we have two terms here. So, once again, I see a little plus here. That's it. Now let's look at B. What do you see that each term has? B squared plus 1, so that goes in parentheses, so we got that. What do we have left on the first term? Negative 2b plus 1. Simple? Okay. Copy these next two and see if you can do these next two by yourself. They should be about the same. That's it. Okay, copy those. Example 3, copy this, 4s times s plus 6 minus 5 times s plus 6. And D is 7x times 2x plus 3 plus parentheses 2x plus 3. Go. Okay, let's see. Do we have a binomial here? Yes, but now instead of addition, there's subtraction. So what's the same here and here? S plus 6. Does everybody see that?
Yes.
And what's left for the first term? 4s and what minus 5. Hands if you got that. Okay, good. Look at this one. What's our GCF? 2x plus 3, right? Because it's a binomial. And what's left on the first term? 7x plus 1. Hands if you got that. Okay, and the last one. Copy this next one down, please. Example 4. Last one. Copy this. No, just this, and then write the word grouping so that you have that in mind. It says, example 4a, factor each polynomial by grouping. Check your answer. 6h to the 4th minus 4h cubed plus 12h minus 8. So here we go. This technique is called by grouping. Pay attention, please. So whenever you see where it says factor by grouping, you do this. I'm going to group the first two terms. Everybody look up. Look at these two. What's our GCF? 2h to the 3rd, because at least each one has 3 of them, right? What do we have left? H divided by 2, that's 3h minus 4 divided by 2 is 2. Are we there so far? Now I'm going to group the other two. And don't forget about the plus. Plus, what is 12h? What's the GCF for these two? 4. And we're left with 3h minus 2. Are we there so far? However, look what we have here now. Who sees it? You see it? So what's our GCF now? 3h minus 2. And what do we have left for the first and the second term? 2h cubed plus 4. And that's it. That's called factoring by grouping. Okay, so homework is found on page, what? 491, numbers 1 through 43. Have a good one, guys. Enjoy your homework. See you guys tomorrow.